experiment 1 is going to be your clippers and clampers. So in that first we will see about your shunt clippers. So shunt clippers, we are going to have, the aim of the experiment is to design and test the diode clipping circuits for peak clipping as well as your peak detection there. So the components required is your power supply, diodes 1N4007 or BY127 there, your resistors. Then procedure is, you are going to make the connections as shown in the circuit diagram. You are going to apply a sinusoidal input Vi of 1 kHz and of amplitude 8 volts peak to the circuit. Observe the output signal in the CRO and verify it with the given waveform there. Apply your Vi and V0 to the X and Y channel of CRO and observe the transfer characteristics and verify it. So your positive clipping circuit. So positive clipping circuit, you are going to have your diode to be in series with your reference voltage. So reference voltage we have taken here to be your 3 volts. So here in this case 3 volts 2.4 they have taken. So now what we are going to do is, your input, your 8 volts Vi input is going to be given through a function generator, where the function generator should be the frequency of that sinusoidal waveform what we are going to give should be 1 kilohertz, and your voltage input amplitude should be 8 volts peak to peak, or it can be 10 volts. Greater than 8 volts it can be. Your resistor is going to be 3.3k resistor there. Your diode is going to be in series with your 2.4 volts. So the output reference voltage should be greater than your 2.4 volts. That means that 2.4 plus 0.7 is going to be 3.1. So in practice you are getting 3. So what you have to remember in shunt clipper is, always the obtained V reference will be greater than the standard V reference. What V reference you have kept, whatever V reference you have kept, that we have to add it with 0.7 volts, so that the total obtained V reference should be 2.2 volts. If I keep the V reference, your obtained V reference should be 2.2 plus 2 volts V reference plus your diode voltage Vd, that is nothing but 2.7. So here you can see that this is a positive clipper. So positive clipper means a positive portion of the waveform is going to be clipped. So you can see that till your V reference, it is going to be your output is going to follow the input. Once at V reference at 3 volts, your output is going to be clipped. So this portion, the flat portion, is going to be called as the clipped region, and this straight line is going to be called as the transmitted region. This is the transfer characteristics of your positive clipper. So here, to find out your R value, so your RF of the diode, your forward resistance of the diode is going to be 100 ohms. Your reverse resistance is going to be 100 kilo ohms. So to find out the R value, it is nothing but square root of RF into R. So if I find out, it is going to be 3.16 kilo ohms. So you can choose your R value to be 10 kilo ohms, or you can choose it as 3.3 kilo ohms also. So suppose if the output voltage we are going to have to be is going to be clipped at plus 3 volts, that means that your V0 max is going to be 3 volts. We know that your V0 max is equal to VR plus V reference. So here your V reference is equivalent to V0 max minus V reference, that is 3 minus 0.7. So your obtained V reference will be 2.3 volts there. So here this is going to be your output waveform, your obtained V reference there. So from your output voltage, given the output voltage to be 3 volts, you can calculate your V reference, or keeping your V reference, we can calculate your output voltage there. Your negative clipping circuit, just reverse the direction of the diodes and your power supply, you will be getting a negative clipper there, and here again your negative portion of the waveform is going to be clipped. So in this transfer characteristics, we can see that the negative portion is going to be clipped, and the positive portion and small portion of the negative side is going to be transmitted. So this region we call it as transmitted region, and this region we call it as a clipped region. So you want to find out your V0 minimum to be minus 3 volts if the output voltage we want is minus 3 volts. In that case, we should find out what should be the V reference value. So your V0 minimum is equivalent to minus VR plus, if you write the KVL equation for the output side of the loop. So V0 minimum is equivalent to minus VR plus V reference there. So in that case, it is going to be minus 3 plus 0.7. It is going to be minus 2.3 volts. So the V reference voltage should be 2.3 volts there. Thank you.